Sorry. Good point, Mara. Because all of us, we forgot. Clara and Elena also forgot to tell me. Well, this is recording now. Did you understood, guys? This was just the explanation. Now I'm going to do a brief recap about the definition that we are going to do. Nelly, you understood? Okay. Guys, this is very important. This is how Grasshopper, we were just reviewing how Grasshopper works with data. Okay? How list, basically data streaming in Grasshopper. We were reviewing also the filtering of the points. Okay? And we are going to do the shear angle, modification in our buildings. I'm going to move this thing away, or I'm going to delete it. Okay. I will repeat this. Don't worry, because I'm going to repeat this through the whole course, because this is, if you understood this, this is the most important point in Grasshopper, guys. This is how Grasshopper works. So for today, we are doing the shear angle modification. For this, we want to, we are working with our unmodified building from the class number 3. This one, okay? It was just we draw the perimeter of our buildings, and then we extrude them based on an attractor point, and this was our building, okay? So this is the geometry that we are using today. We are going to use the shear angle modification in our buildings. So for this, I want to modify the base. Okay, so I obtain the base of my buildings. I put a plane in the center, and then I do the modification of these buildings. Okay, based in this plane, in this geometry, and finding the distance between the center of these surfaces and an attractor point. The problem that we are having, and this is why we enter in this explanation of the data streaming, data matching in Grasshopper, is because in this component I am entering here with a list, which are my buildings, but suddenly this list has exploded into a tree. You know, so in the component, I am going inside the component with a tree and a list. Okay, so guys, if you understood the previous problem, Nelly, Mara, now that you talk before, how can I solve it? How can I solve this issue?
Is there maybe a way that you can simplify the tree structure so that it is only one?
Super, Nelly. That's the thing. There are two ways of solving it. Two ways. One is, or as Nelly is saying, I simplify my tree. In other words, I transform this tree into a list, and then I have 3 items in my list. But not only this one, also this one. Okay, also the distances. Or I simplify this tree, or I convert this item in a tree. Okay, let's going to do both of them. Okay, let's going to do both. Nelly, how to simplify this tree in a list?
I just remember we once did this with a right click on the panel on the I don't know how's it called component.
Yeah. Right click on the component, on the output of the component, and you. This is the lottery, Nelly. You have the next options: reverse, flatten, graft, or simplify. Which one?
I would choose simplify.
No. Take a look what is doing simplify. My tree has here 2 numbers per branch: 0, 0, 0, 1, 0, 2. Simplify, what it does, I mean, right now, this 0 is giving us non-information at all. because I have branch number 0, branch number 1, and branch number 2. I can omit this 0. The first digit in the branch index, I can omit it. So if I do here simplify, you see, is removing the first index. Let's gonna go 1 second to my tree drawing that you have it in the class number, sorry, in the class number 5, I think. Yeah. You see, for example, in all these three, at the end, the branch number 0, I can delete it. It's not needed, this first index. Because if I will have a tree with 2 branches, with 2, I don't know how it's called this part, like the basal area of the tree. If I have suddenly a tree that has here 0 and suddenly, can I draw here somehow? Yes. And here suddenly you have another part of the tree that this is 1, then the 0 I will not be able to delete it when I do simplify, you know? But if I simplify my tree, all these indexes are going out. This, forget about it. All these indexes are going out since I am only having 1 branch. Okay, I am still having the same data structure, but as simply as possible. All this will go out, all this will go out. You see that is this 0 on the left is not important at all in this case, in this tree that we are seeing in this image. Good. Basically, you can see it here, right? In the param view representation, all this 0, I can delete it because it's giving me no info. This one I can't. The next digit I can't because here I have the 0 branch. Then we go for the first. Then here I have the second. So there is a order implemented here. But the first one was totally optional. Let me delete all this. Let's go back to Rhino. So then when I do the simplify, Nelly, I just clean my tree. Remove branches which are not important for us. Okay? Then what can I use? Reverse the order. If you there is
Perhaps
something.
flatten.
Yeah, it's flatten. Yeah, Tianji, very good.
And
If you use
both
reverse,
this one, the distance.
yeah, we use it once, I think. We use it once flatten. Very good. But let's go to review it. Reverse. What is reverse? At the end, reverse, what it does is if you have a tree, it switch the order of the elements in the tree. So you have a tree with multiple. Where do I have a tree with multiple items? Let me see. Maybe this? No. I want a tree. I'm gonna get one tree from the next classes, okay? But it has to be a simple one. This is what you are going to do in the next classes. Okay, this is a huge one. This one. Well, yeah, let's go to do it like this. I go here. If I reverse here, what it's going to do is the order here will change. 7.08 will be the first one, and then 0 will be the last one. You know, so it's going to reverse the data inside each branch. Okay? Remember this, please. Remember this. The most important ones are 2. Flatten. If I flatten the output, you see, I convert this in a list. So flatten, you always associate flatten with list. I convert a tree into a list. This is flatten. Okay? So if I flatten this one and I flatten also that one, the shear angle is solved. I mean, it's solved, but it's huge. You know? It's solved, but it's like buildings are literally going super crazy. Doesn't happen the same with you guys? Oh, whoa. It's very. Doesn't happen the same? Okay. Yes. So let's going to fix this problem later. But at the end, the problem of our data is solved. We again have those three buildings. Okay? The other way around. I don't want to convert this in a list. I don't want to. I want to still work here with my tree. How can I do the first one? You remember that we said that there are two options. One of them, simplifying the list, transforming the list, simplifying the tree, transforming the tree into a list, basically. First one. Second one, transforming my list into a tree. Okay? Both of them are the same. It's just data match structure. Okay? Match the data of all the inputs in the component. Match the data structure of both inputs in the component, of all the inputs here. Okay? How can I transform this list into a tree? Right mouse button, graph. The thing with graph is that you need to check that now your definition is working, because if you graph this, okay, here I have a tree, seems that it's going to work. Yes, yes, yes. No, it's not working now. Or yes. Ah, yeah, it's working, sorry. Yes, yes, it's working. I have my surfaces, the area, the point. Yes, it's working. But you need to, when you graph, the problem of grafting at the beginning of a definition, guys, is that you need to check that all the steps are working again. Because maybe some of these steps here doesn't work. You know? Okay, so then the problem is solved, okay, with both solutions, or grafting here or flattening here. I prefer flattening at the end. So let's going to remove graft here, and let's going to flatten this one and this one. I prefer flatten just for the order that we follow, because we did this definition with this component being a list. If I grab something here at the beginning, I will need to, as I say, double check that everything is working. And this may take some time. Good, guys. So, we have solved the data structure problem. Now there is another problem. Our buildings are going too crazy, no? I mean, this is not possible. This building is literally laying on the floor. Oh, yeah. You see, they are, it's like they are playing a very weird game. Okay. How can I solve this? Can somebody guess? What is AX and A?
Maybe a maximum angle that they can tilt.
Yeah. That's it. A maximum angle that they can tilt. How to do this maximum angle, Leona?
So maybe the distance can't go any further than a certain amount.
Yeah, super. That's the idea. That's the thing. The distance can't go any further than a certain amount. Whenever you want to put boundaries in a number, like I don't want this number. You remember when we did if I go back to our definition of the class number 3, you remember that we were doing the heights of our building based on this attractor point? And I told you, hey, bye, guys, but the city council told us that regulations told us that the building can't be higher than 75 meters. So we did a construct domain and we remap those distances to a certain boundaries. We put boundaries in our component. So at the end, what we have to do is literally copy paste exactly this process and put it there. I'm not going to copy paste it, you can, but I'm going to think about it again and do it again. So because I have the feeling that I don't know you guys, but I learn better things when I understand what is going on than when I just learn it by heart. If I learn it by heart, tomorrow I forget it. So is remap numbers the one that we want to use, right? Remap numbers. We have the values, we have the source, and we have the target domain, source domain, target domain. What values do we want to remap? I want to remap the values of the distance, okay? Source domain, what is the source domain of this distance? So the source domain will come from a component called bounds, okay? Bounds. Create a numeric domain which encompasses a list of numbers. Here we go. If I connect this one here and this one there, here we have the domain of these distances, whatever they are, okay? And then the target. Okay, so my target domain is going to be from one number to another one. This number that we are providing here is a bit weird because it's in radians. Rotation around x-axis in radians. Let's going to just try, okay? Let's gonna try something that looks good and is not huge different, and later we can modify it. So we are going to construct domain, okay? We are going to use this component, construct domain, okay? With A and B. A is the minimum, B is the maximum. Our domain is gonna go from minus 1.00, sorry. Minus 1.00 is smaller than 1. From minus 1 to 1. This is going to be my slider. Let's gonna copy paste it 2 times and let's going to see how it works. I am going to put a slider from 0.22 and minus 0.43. This is going to be my bounds and this is going to be the target. And now what I have out of this number, out of these remap numbers, are the numbers remapped. And those numbers are the one that I'm going to connect here and there instead of the distances. Okay? Here I go. Good. So let's see what's going on now. Let's gonna just try by checking. Okay, this is way better. You see the buildings are, you have to take care because sometimes they are clashing with each other. But it's very cool. You know, now it's working. Now we can say that this thing make sense of it. You see, we can modify the buildings according to our attractor point distance. Okay? It's okay, guys? Also, you see the floor plan of this is like interesting because I usually like this type of floor plans that people draw, which is like, I don't know how it's called this type of view. It's isometric. I don't remember. I am always very bad with this, with the name of views, depending on the angle of the drawing. Understood this here angle. Let me move all this. Here. Understood this here angle, guys? Okay. Let me open the chat because I don't open the chat for a while. No questions. Good. Can we continue? Okay. Yes. Very good. So we have done the modification that was planned for the other day, but I thought that it was too much and I leave it for today. And for today, also, let me put a white one. What we are going to do is we are going to get our buildings. So I'm going to put a geometry component here. We are going to get the buildings of the other day and we are going to splice it. Can be the buildings of the other day or the shear angle buildings. Doesn't matter. We can use this one. We can use this one. Wait a second. We can use this one, the one that we have done with the twist, the one we have done with the how was called scale non-uniform, twist. We have here the buildings that they were like rotating. We can use the one that you want. At the end, the modifications we have done are this is the construct plane. Wait a second. Yeah, this is the building that they were rotating. Okay. Then we have the twisting. Then we have the ones which are like scale non-uniform. Okay. And this is the option of this. We are not going to continue with them. Okay. This we are not going to continue with them. Don't worry, because as I said, the next day we are going to organize the whole definition, okay, of the course. Because I see that we have here starting to have a lot of stuff and we need to organize things a bit. Okay? We go class 0, we did this, class 1, we did this, little by little. Okay? So I'm going to use, for example, the buildings that they were twisting. Okay? The twist modification we did last class. So I'm going to connect this geometry from here to here. By the way, it's a 3. Okay, as soon as I see this, I know that this component is a 3. Okay? What are we going to do? Whatever geometry we have, whatever
Sorry,
geometry. Yes, Kemi.
can you show again which one you connected it to?
I am using the one that we did last class, which is the one that is twisting. Kemi. Okay? But you can use this one, or you can use the one that is like a cone shape, the scale non-uniform, or you can use the one that we have used today also, the shear angle. The shear angle component, the only thing is that from now on we are going to work with trees. Okay, so the output here, graphed. Okay, graph the output. So we want a tree out of here. Okay? Shear
Okay,
angle.
thanks.
You're welcome. Shear angle component. By the way, I'm gonna move a little bit this one because it's like something here. Yeah, here we go. This one is coming in there. This one is coming there. This one is coming here. I'm gonna make it a bit smaller. Yep, here we go. Good, so those are my towers, okay? I am going to create the levels in my towers, the floor plans, because next day we will use these floor plans. To create the levels, we are going to use this component that is called contour. Super simple, okay? And we will contour our geometry. Contour can be used in many situations, vertical, horizontal, whatever you want. This is just to create like cuts in one element. And then, yeah, we will just basically, wait a second, because here I did something wrong. I think that this was part, no. Here I have surfaces and the points. But this is for the next class that we will need it, but it's not very necessary. Okay, so this is the class of today is still here, okay? We will use this contour to create like the different levels, okay? So we have here our building. Let's gonna use the contour component. That should be very easy. Contour. There are multiple contour components, by the way. Is contour, this one, create a set of B-rep or mesh contours here, okay? So what is asking this component as inputs? S, P, and D. S is shape. B-rep or mesh to contour. P is the point where the contour starts. N is contour normal direction, the direction where you want to cut your geometry, and D is the distance between contours. Okay? So at the end is like this. I didn't put here any point where the contour starts. By default, start at 0, 0. Okay. By default, the contour component, the P, the input P is 0, 0, 0, is this point. Okay? By default, you see when I select the contour, I have selected the point here appears in green when I select the component. So we can literally just connect this one here, okay? And just give a distance of a number that is going to be your floor height, okay? So let's gonna put a number from, I don't know, 1.00, says smaller than 6. The maximum is going to be 6 meters between floor plans, the minimum or whatever, the minimum 1, okay? So let's gonna put 4.35 or whatever and put it in D, and this should be working. Okay? So here I have now my contours. You see? It looks cool in floor plan, no? Okay, guys? So here we have the contours. Good, Nelly. Very good. From now on, this is important, guys. From now on, let's connect a panel. Check what is going on here. From now on, from this component and all the rest of the class, we are going to work only with trees, unfortunately, okay? And we are going to, we have to be very organized and follow the same structure, okay? So what is happening here? I am entering the contour component with my tree of buildings. Building number 1, building number 2, building number 3. This is my tree. The contour component, what is going on here? Is generating this tree. Branch 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, 1, 0. 1, 1, 1, 2, 1, 3. Now it's time for you, since we are going to work with trees from now on, guys, it's important that you use one component that is called param viewer, okay? Param viewer is the same. It's very similar to panel, but panel, you use it for list. I have used it until now because it was like simple trees, but when I am dealing with complex trees, I am going to use param viewer. Okay, param viewer. And if I connect this one here, it's going to give me the information of my tree. So my tree has 37 branches. On every branch, it has one item, only one item. N is the number of items. And it's like this. If you double click the param viewer, you can see a representation of your tree. Okay, like a graphical representation of your tree, like this one that I showed you before. Okay, this is more beautiful, but the principle is the same. You have a tree with 3 main branches. On every branch, each branch has different number of branches. For example, branch number 0 has only 5 branches. Branch number 1 has 12 branches. Branch number 2 has 17 branches. Understood? Okay, good. Now here comes the question. What is branch number 0? What is branch number 1? And what is branch number 2? What are those 3 branches?
I think those are my 3 buildings.
Yes, exactly, Nelly. Exactly. Those 3 branches, each branch, each one of those big branches are your buildings. So I can tell you right now that branch number 0 is the small one. Branch number 1 will be this one. And branch number 2 will be the biggest one in my case. Why? Because I am setting a distance of 4.35 for the planes. And of course, this one has more planes than this one and then this one, right? So what this component is doing is each one of those polylines is assigned to a different branch. Okay? The thing is, do I want to keep this data structure like this? One branch, one item per branch? This is a bit too much at this moment. We will need it before, but at this moment it's too much. What I want, the perfect data structure for me right now will be branch number 0, and here I have whatever 30 items. Oops, sorry. Branch number 0, and here I have like this, and equals, imagine 32 items. Branch number 1, building number 1, and equals, I don't know, 5. This is going to be the small one. And then branch number 2, I have n equals 20. For me, at this time, oh, what is going on here? What happened here? Okay. Is the first time I received this issue. Okay, well. Okay, so 0, 1, and 2. Okay, I have it like this, having only 3 branches, 1 branch per building, and on each branch, I store all the polylines. Okay, how to do this? If I flatten this, I am killing my tree. So now I have only 1 data with all the polycurves, all the polylines inside, but I don't know which polyline is for each building. I have no idea. With this, I cannot work. So flatten is not an option. I don't need to flatten. What I need to do is at the end, cut. I have to prune my tree a little bit. I need to cut one of these branches and remove. Actually, I want to remove this one. I want to remove this one. This level, I want to remove it for all these items. I am sorry, guys. I don't know what is happening with me today because I am like, yes, I am touching like all the buttons here and I am making a mess out of this. All these numbers here, I want to be assigned to the branch number 0. I'm having a list. This is what I want. So for this, what I need to do is one component that is called trim tree. I want to prune, I want to trim my tree. Okay? The tree that I want to trim is this one, and the depth. The depth is number of outermost branches to merge. Okay? Outer branches are the ones on the right. Outer branches, as you can see, are the ones on the right. The tree is growing from left to right. So 0, 2, 0, 2, 1, 0, 2, 0. 0, 2, 1, 0, 0, 2, 1, 1. You see? It's always growing to the right. Those are the outer branches, not the left. Okay? So then, if I put a depth 1, what I'm doing is I'm deleting this branch, the outer branch of the tree. Okay? So then what will be my data structure out of here? Ta-da! What I want. This is what I want. Branch number 0, branch number 1, branch number 2. Okay? My 3 buildings with my floor plans per building. One has 6 floor plans, 13, 18 floor plans. So this is the output that I want out of here. Okay? From here, I can convert these polylines into surfaces because we are going to work with surfaces. So for this, just put a surface component. Okay? Surface component here. We have it. Okay? And then we have our floor plans. This should work with all type of geometries you want. For example, with the building that we did today, with the shear angle, let's go to connect the shear angle here. I connect the shear angle. I have the contour of my shear angle. Okay? And I have again my surfaces. As you can see, I'm going to delete this thing, guys. Param viewer. Param viewer. So here I have my param viewer, and I have again 3 branches. The thing is, in this case, is 0, 0, 1, 1, 2, 2. Nelly, sorry for asking you so much. Do you think that we need 2 branches here for this tree?
I think no, because it's just a repetition of the number.
One is redundant, right?
Yes.
One of them is not needed at all. So now, Nelly, now we can use simplify. But with simplify is not working because it's like using the yeah. Let me 1 second. I think that the solution come out of here if I simplify this one. No. The problem is coming out of here. Just here I can simplify, I think. No, I'm grafting here. I want to simplify and don't graft. Yeah, now yes. Nelly, one thing that I want to explain you. Simplify. If you simplify your tree, you say, hey, but this should work, right? Because if I simplify here, I should remove redundant data branches, right? And for example, this one is completely redundant. I don't need it, or the other one, I don't care, or the one on the left or the one on the right, but I have only 3 branches. I don't need 0, 0, 1, 1, 2, 2. Okay? I have 0, 1, 2. The problem is simplify, the way that they have programmed this is that it only cleans zeros. It is not going to clean data when it detects that there is a 1. If it detects that here there are 2 numbers that are different, it's not going to be cleaned. So you need to go back in your definition and check where you can do the cleaning. From contour, is not going to work neither because I don't think so. It has, you see, it's not working neither because it detects that there are differences on the tree, on the 3 levels of branches. So simplify here is not working. Let's go back again a little bit more. With geometry is going to work. Why? Because simplify detects that here I have same number, same number, same number. Can be deleted. So if I simplify here the tree, then I am having only 1 branch. Then here I'm having only 1 branch. It's not, you tell me, Javi, but I can't continue the course if my data is like this. You can continue the course. You can. Okay, guys? The problem is that we are going to work the next days. We will work in complexity. We will start filtering and creating different patterns on these floor plans, extruding those floor plans, filtering elements in those floor plans. Some of them will be extruded, some of them not, depending on a tractor point, and is going to be more difficult. Okay, so at this point, I recommend you to keep it as simple as possible. Okay, in this case, simplifying here, do the job. Okay, it's recommended to have actually here the simplify always, because simplify is not going to, let's say like this, simplify is not going to modify your definition. If your definition works without simplify, with simplify it's going to work the same way. But if you flatten or graft elements, maybe not. Okay? Flattening and graft are very, they modify the way that Grasshopper is interacting with geometry, with information. Simplify just making things easier. Okay, so we can keep simplify always here. So as I was saying, we can connect the geometry of today, the geometry, for example, this one that we did the other day. Let's go to connect it. Okay, we simplify the tree, and then we have again, you see? We have again our surfaces. Okay, so somebody was asking me, hey, Javi, what geometry did you use before for creating the building, the floor plans? Doesn't matter. Check that we can reduce reduce the height of our floor plans. Then, of course, we will have more floor plans, or we can increase it and we will have less. You see, right? My recommendation is keep this a big number, like 4.7, 4.6. While you are working with Grasshopper in the class, don't reduce it to 2, for example, because then we will start working with every one of this, and it's going to be a little bit heavy for the computer. Okay? Well, guys, that was for today. As I told you, it was a quick class, but we finished around 11 at the end. It was a bit quick. Any questions with those two definitions we did today? Sorry, because I forgot to record the first part, but I think that is also the students that are here with me working, you should have also an advantage from the rest, right? So you receive this part of the trees. If somebody have a question, don't hesitate to contact me. This is what we did today. And I think it's kind of easy. This year angle today was easy, and the contour was also super simple, right? It was just the shear angle was just obtaining the geometry, exploding the geometry, finding the bottom face. We have done it a lot of times. Then putting a plane on those faces in the center. And the shear angle is requesting the geometry that you want to do the modifications, then a plane to apply this modification, and then those are numbers to rotate to shear your building. So I just did it with an attractor point and the center of each one of the faces, and then calculating those distances is the one that we are using to shear to modify our buildings, okay, based on a remap numbers. Very simple. This is what we have done a lot of times also. So for next day, we will organize our definition, please. So for next day, it's very important. Bring your definition to the class clean already. If you don't have clean, I hope so, that you have already clean. And we are going to organize everything, okay? We are going to organize all the modifications, prepare everything, okay? Because I have much more than you, because I have also here some tests and stuff that I have done by myself. But yeah, I will only have the definition that we have done in class, okay? Good, guys. Any question till here or no questions?
My surface command goes red if I connect it to the geometries we did last week, but if I connect it to the ones we did today, there's no error.
Your
And it
contour,
says,
you mean your contour?
the data conversion failed from curve to surface.
Yeah, of course. Is contour, Leona, the one that is in red?
Yeah. No,
Yeah.
the surface one. The one all the way to the right.
Here?
That one.
But what is the output out of here? What is the output out of here? Is that a polyline curve?
Planar curve.
Can you share your screen, Leona?
Yeah, give me a second.
Give me a second. I'm going to allow everyone to share. Let me have a look. I'm going to stop recording, okay, guys?